Good morning everyone. Since we are done discussing about the asteroids, so now let's discuss the other debris in our solar system, which is the comets. The comets are also known as the long-haired stars or the hairy stars. Before we proceed with our discussions, here are the objectives that we need to meet as we go on with our discussion. Our objectives are, by the end of this section, you will be able to first, characterize the general appearance of comets, explain the range of cometary orbits, describe the size and composition of a typical comet's nucleus, discuss the atmosphere of comets, and summarize the discoveries of the Rosetta mission. Comets differ from asteroids primarily in their icy composition, a difference that causes them to brighten dramatically as they approach the sun, forming a temporary atmosphere. In some early cultures, these so-called hairy stars were considered omen of disaster. Today, we no longer fear comets but eagerly anticipate those that came close enough to us to put on a good sky show. Sinasabi na yung comets differ from asteroids although they are same rocky materials from the space. They are different because of their icy composition that causes them to brighten as they approaching the sun. In early times, comets symbolize a disaster, death, and suffering. The appearance of comets. A comet is a rare, relatively small chunk of icy materials, typically a few kilometers across, that develops an atmosphere as it approaches the sun. Later, there may be a very faint nebulous tail extending several million kilometers away from the main body of the comet. Like the moon and planets, comets appear to wander among the stars, slowly shifting their position in the sky from night to night. Unlike the planets, however, most comet appears at unpredictable times, which perhaps explain why they are frequently inspired fear and superstition in early times. Comets typically remain visible for periods that vary from a couple of weeks to several months. We'll say more about what they are made and how they become visible after we discuss their motions. Note that still images of comets give the impression that they are moving rapidly across the sky like a bright meteor or shooting star. Looking only at such images, it is easy to confuse comets and meteors, but seen in the real sky, they are very different because meteors burns up in the atmosphere and gone after a few seconds, whereas the comets may be visible for weeks in early same part of the sky. Comet orbits. The study of comets as members of the solar system dates from the time of Isaac Newton, who first suggested that they orbited the sun on extremely elongated ellipses. The picture shown is the comet Halley, which is shown by a large telescope in Chile during 1968. This comet was named after Edmund Halley, in giving honor of the first astronomer who recognized it as a permanent member of our solar system orbiting around the sun. Halley published calculations of 24 comet orbits. In particular, he noted that the orbits of the bright comets had appeared in the years 1531, 1607, and 1682. Were so similar that the three could well be the same comet returning to the perihelion or the closest approach in the sun at average interval of 76 years. And also, he predicted that the comets should next return about 1758, but Halley died by the same time the comet appeared as he predicted. Sa table na ito, makikita natin yung iba't ibang comets na na-discover ng iba't ibang astronomers and its significance. Say for example, the comet Halley, where sabi dito sa table na ito, it is the first comet found to be periodic explored by a spacecraft in 1986. The comet's nucleus. When we look at an active comet, all we normally see is its temporary atmosphere of gas and dust, illuminated by sunlight. This atmosphere is called the comet's head or coma. Since the gravity of such small bodies is very weak, the atmosphere is rapidly escaping all the time. It must be replenished by a new material which has to come from somewhere. The source is the small, solid nucleus inside, just a few kilometers across, usually hidden by the glow from the much larger atmosphere surrounding it. The nucleus is the real comet, where the fragment of ancient icy materials is responsible for the atmosphere and the tail. The water vapor and other volatiles that escape from the nucleus when it is heated can be detected in the comet's head and tail, and therefore we can use spectra to analyze what atoms and molecules of the nucleus ice consist of. We have never identified a fragment of solid matter from a comet that has survived passes through the Earth's atmosphere. However, spacecraft that have approached comet have carried dust detectors, and some comets has even been returned to Earth. It seems that much of the dirt in the dirty snowball is dark, primitive hydrocarbons and silicate rather like the materials thought to be presented on the dark. This photo shows the different parts of the comet. As you can see, the coma is the head of a comet, while inside of it there is a nucleus. The nucleus is hidden because it is so bright, and another part of the comet is the icy fragment materials is what we call tail. A comet consists of two tails. First, the ion tail, where consists of gas and dust that can be extend hundreds of millions of kilometers away from the coma, and the dust tail, which appears whitish yellow because it is made up of tiny particles about the size of particles of smoke that reflect sunlight. This photo is a captured comet dust where it is seen through a microscope. These particles believed to be a tiny particles of cometary dust collected in the upper atmosphere of the Earth. And this photo is the historic photograph of the black irregularly shaped nucleus of Comet Halley. It is obtained by the ESA Giotto spacecraft from a distance of about 1,000 kilometers. The bright areas are sets of materials escaping from the surface. The length of the nucleus is 10 kilometers, and details as small as 1 kilometer can be made out. The comet's atmosphere. The spectacular activity that allows us to see comets is caused by the evaporation of cometary ices heated by sunlight. Beyond the asteroid belt, where comets spend most of their time, these ice are solidly frozen. But as comet approaches the sun, it begins to warm up. If water is the dominant ice, significant quantities vaporize as sunlight hits the surface about 200 Kelvin. This happens for a typical comet somewhat beyond the orbit of Mars. The comet continues to absorb energy as it approaches the sun. A great deal of this energy goes into the evaporation of its ice as well as into eating the surface. However, recent observations of many comets indicates that the evaporation is not uniform and that most of gas is released in sudden spurts, perhaps confined to a few areas of the surface. In this photo, we see the cloud of gas and dust that make up the head or coma of Comet Halley in 1986. On this scale, the nucleus is hidden inside the clouds and it is too small to see. Most comets also develop tails as they approach the sun. A comet's tail is an extension of its atmosphere, consisting of the same gas and dust that make up its head. As early 16th century, observers realized that comet's tail always point away from the sun, not back along the comet orbit. The orientation of typical comet tail changes as the comet passes perihelion, approaching the Sun, the tail behind incoming comet head, but on the way out the tail precedes the head. As you can see in this photo, the smoother dust tail curves a bit as individual dust particles spread out along the comet's orbit, whereas the ion tail push more directly outward from the Sun by our star's wind charges particles. As a comet nears the Sun, its features become visible. Photo from NASA showing the comet Hale-Bopp. You can see a comet two-tail, the ion tail or the gas tail, and the dust tail, which is the visible one. The next photo is the comet Marcos, and it is photographed in 1957 with a wide-field telescope at Palomar Observatory. The Rosetta Comet Mission. In the 1990s, European scientists decided to design a much more ambitious mission that would match orbits with an incoming comet and follow it as it approached the Sun. They also proposed that a smaller spacecraft would actually try to land on the comet. The 2-ton main spacecraft was named Rosetta, carrying a dozen scientific instruments, and it is 100-kilogram lander with a 9 more instrument was named Philae. The Rosetta mission was launched in 2004. Delays with the launch rocket caused it to miss its original target comet, so an alternate destination was picked. Comet Churyumov-Gerasimenko, named after the two discoverers, but generally denoted 67P. This comet's period of revolution is 6.45 years, making it a Jupiter family comet. The first image is from Rosetta camera and was taken from a distance of 285 kilometers. The resolution is 5 meters. You can see that the comet consists of two sections with a connecting neck between them. The other one is the close-up view of Comet Churyumov-Gerasimenko, and it is taken using the Philae lander. This one is photographed from Rosetta spacecraft near at perihelion. You can see a jet suddenly appearing. It was active for only a few minutes. And that's the end of my discussion. My name is Christian Miranda Bigay. Thank you for listening. Have a nice day, everyone.